Today's lesson is about functions. In grade 10, you learned that y is equals to ax squared. It was a parabola. It was a parabola graph. But what I must know about this graph, if I'm having my a is less than 0. If my a is less than 0, it means my a is negative. Therefore, the graph will be like, it is negative. It means the graph will be set. If the graph is set, it's like this. Whereas in this graph, I don't have a minimum. It means my domains are the x values of this graph. Therefore, my domains will be x, will be the element of real numbers. These are my domains. Why am I saying x is the element of real numbers? This graph, my x values, here are my x values. Whereas what I see, I'm from negative x values to positive x values. It means they are all real numbers. Whereas, if I can see, if my a is greater than 0, if my a is greater than 0, it means my graph is smiley. If it is smiley, it will be like this. Therefore, here I'll be having my domains. Will be x is the element of real numbers, because I'm from negative x values to positive x values. From the first graph, where we said that a is less than 0, what is my range? The range I'm going to talk about is the y values. Here is the turning point. It means for me to have my range, I'll be having the turning point. And here in grade 11, we'll be taught that our turning point, I'm having a formula which is y is equals to ax squared plus bx plus c. This is the function I'm going to be dealing with. Therefore, for me to find a turning point on this graph, I must have my x, which will be equal to minus b over 2a. For you to find this, please take this. Ax squared plus bx plus c is equals to 0. Take this. Here, solve for x by completing the square. Therefore, if you are solving for x here by completing the square, you are going to have x plus b over 2a, which will be plus, here I will be having b squared minus 4ac all over 2a all over 4a, which is equals to 0. Here, if I'm solving x from this instance, I'll be having x plus b over 2a is equals to 0. Therefore, I'll have x as minus b over 2a. But I'm having different graphs or expressions of a quadratic function. Here I'm having y is equals to ax squared plus bx plus c. This is my expression. But I'm having a graph of y is equal to a into x plus p all squared plus q. Here we are talking about the shifting of the graphs. P, if I'm told that my p is positive 1, p is the horizontal movement of the graph. If my original graph, as from grade 10, what you were taught, it was y is equal to x squared. This graph will be like this. Firstly, what I noticed is that my A is positive. It means my graph must smile. But here, this thing must change. I'm having a P. And here my P, what if they say to me that my P is equal to negative 1? If they are saying my P is equal to negative 1, please, you must never and ever, this graph, the original one, where it comes from, it says y is equal to a into x minus p squared plus q. If they are telling you that p is negative 1, so please subtract negative 1 where you see p. Therefore, your graph will be y is equal to a into x minus into. My p is negative 1. Here I have negative 1 all squared plus q. But if I'm told that my p is negative 1, it means this graph shifted 1 unit to the left because it says negative. If this graph shifted 1 unit to the left, it means it will be like this. It shifted 1 unit to the left. Here was my turning point. It was 0 is to 0. But now it changed because it shifted 1 unit to the left. Here it will be negative 1 is to 0. This is the value of my turning point after 1 unit to the left. But what if they say my graph is, my P now is, let's take our P as 2. If our P is 2, therefore we are going to have y is equal to a into x minus into the value of my P is 2. Here is 2 plus q. Therefore the 2 will be 2a into x minus 2 squared plus q. They say it shifted 2 units to the right. If it says 2 units to the right, check the sign is negative from the original graph. Therefore, if it is x minus 2, the graph will shift to the right because they say our P is 2. If it shifts to the right, it will be like this. Let's say this graph is f at x, this one is g at x, this one is h at x. Therefore, h at x will be this one. This one will be h at x. Whereas this one is our original, which is f at x. Whereas this one is our shifting to the left 1 unit, which was g at x. Please, this shifting are more important to you because you must conclude in each and every graph. But after here, I'm having a graph which says that my first graph was ax squared plus bx plus c. The second one, this one. Where must I use this formula? I must use this formula where I'm having my turning point. My turning points. What are my turning points? In each and every graph you are having here, your turning points is this points, these 2 points. It means my turning points are P is to Q. This is the coordinates. It means his P is to Q. But I'm having the third graph, which is y is equals to a into x minus x1, x minus x2. This one is also a parabola, but where must I use it? I will use this one, this formula, where I'm having 2 x intercepts and a point. It means I'll have 3 points, where 2 of them will be my x intercepts and just a point. Here we can see that I've written x1 and x2. It means that my x-intercepts will be replaced by x1 and x2. Therefore, the final point, the third point, will be substituted in this formula to find A.